A quality requirement is a specified achievement level of a quality attribute, security. Now, I can have security with username and password. I can have security with username, password, and 3 annoying questions. Or I can have retinal scanners, right? I mean, I can do this at various levels, so we have to say, yes, I want security, and I want security at this level. And then we got a requirement on our hands. We have to figure out how to do it. Quality models are embedded in requirements models. Requirements, how many different kinds of requirements are there? And there are quality requirements, and then there are quality mitigation functions to achieve those. That's part of the requirements also. That's a derived requirement, right? If you say you need quality at this level, then there are probably only a very few ways to get it, and you've got a requirement to choose one of those 3 ways. Quality goals should be derived from useful quality models. That's what these slides are all about. They're going to show you how I define useful, and then why the simplistic models are not. Okay, so what makes a quality model useful? Well, what do I have to do about these quality models? Well, I've got to select the ones that are relevant to my project. I need to identify the other qualities that support the quality I care about. And if it's safety, that's pretty much everything else. And I've got to specify the goals, the levels, and the priorities for each of these individual qualities. And then finally, I need, for the selected architecture, you know it's hidden in there, design and achievement monitoring and verification strategies. So you've seen those before. For each quality and estimate of effort. Now, if you're doing iterative development, which some of you are doing, right, then those strategies, you need to know all the stuff you need to do. So when you get down here and you got a strategy, the strategy is going to work incrementally. Right? Business analyst body of knowledge. Almost alphabetical list of 15 qualities. Does it help you select? Could. Does it help you identify dependencies? No. Does it help you figure out how you're going to achieve any of them? No. So it isn't going to do much for you. Simple lists, no matter how long they are not going to do much. Oh, here's the thing I told you was a simplistic model, the ISO standard. It's got a little bit of structure to it. So if you want to do reliability, you need to do maturity, availability, fault tolerance, and recoverability. Internal qualities, which support everything else, are tucked under maintainability. So this notion of analyzability, testability, whatever is under maintainability, I will claim that that supports everything. So basically, if your code sucks, meaning it can't be understood easily by any competent reviewer, the rest of it doesn't matter. You know? Even if the system works perfectly when you field it, rarely do you put a concrete wall around it and say, excuse me, don't change anything in here, because nobody, including the author, understands everything that's going on. So eventually, if your code sucks, it will destroy the system as a whole. And unfortunately, as a consultant, I've been called in with a partner of mine. They said, we've got a piece of software here that accounts for about 30% of our business, and we're not testing it very well. Could you help us? So we gathered all the developers in the room, and we said, how many of you understand it? No hands. We said, I think you don't have a testing problem. You have an understanding problem, right? So here are those 4 agencies that I talked about that are certifying 90,000 professionals based on the 3 simplistic models. Functional, non-functional, okay, for the types of requirements. It's got that list that I just showed you of 15 almost alphabetized things, and it's got a process that looks like not much. Okay, no, here's a little better. We're going to go into a book on software architecture. Now, this is a topic I know nothing about. I do know that these people seem to care about these requirements because they have an alphabetized list, short, but the good news is they got a bunch of pages after it with various details talking about what these things mean, how you would make it happen. So that's good stuff. Okay. Now here's the best-selling book in software requirements. They got two sets. They got internal and external qualities, and they've got this terrible, I don't know what to call it, a model of the relationship. Now I would have thought that everything above the median and everything below the median would be perfectly symmetric and you'd only need half of that, but that's not true. So I don't actually know how to read this, but it's not reader-friendly in any case. So I'm going to show you very quickly. We're now going to get into hyper mode. This is video mode. This is an essentially complex model. It's online, 125 pages. Okay, so I've got three categories. There's these internal guys. There's the external guys. Those are completely visible to the user and the developer. And then we've got these iceberg guys. So something like safety. You can't look at a system or run a bunch of things against the system and go, oh yeah, that's safe, no problem. I mean, you can run some stuff, but then you better look inside and go, let's see, we got this hazard list here somewhere, and we got a set of mitigations against the list, and are all of them taken care of? Are they all here? So we got some external stuff and some internal stuff, which is why I call it mixed. We're going to take a look at three of those. This is, quote, so big that it has to be in two panels, right? So basically, this panel is the explosion of this guy. And you see understandability, standing tall in the first position. If your code is not understandable, if your systems design is not understandable, bad things are going to happen across possibly a long time frame, like 20 years of bad things are going to happen because every time anybody touches the software, it breaks. This is mainly verified by reviews, analysis, and measurement. In many developers' heads, there are functional requirements and testing. That's it. How sweet it is. The world is such a simple place. Well, it's not. You've got to become really good at technical reviews. I'll call them skeptical technical reviews. What does that mean? That means you believe it doesn't work. And you set about proving that it doesn't work. And only after you've done that a lot and failed might the idea that maybe it works creep into your head. Okay? And I can tell you from personal experience, it makes a huge difference about whether you think something is okay or works and whether it doesn't. So the orientation of your head before you review anything is enormously important. Got to do all kinds of analysis, all kinds of measurement to make sure. Now, we got some of the things like monitorability and controllability that, yeah, actually require a little testing, but mainly that's not what it's about. Runtime, self-checking, design and coding standards, understandability. For me, three pillars of internal quality. And I care a lot about this. The customer will never see it. They'll see the consequences of not having it, but they'll never see the consequences of having it. Okay, now we got external guys. So this is an external guy and this is a mixed guy. The external guy is correctness, blah, blah, blah. You all understand that. Over there, you see a little square brackets that says that this isn't mixed, but it is supporting safety. So if you're into safety critical, guess what? According to this model, you got to worry about a lot of other quality attributes that aren't even in anybody's spec. They're just saying we got a safety critical application. Oh yeah? Okay. Then you got to worry about how you're going to achieve security, achieve robustness, achieve external all of the items in the external rent. It's very expensive. Now, of course, you make it cheaper by ignoring it, right? We don't know how to do that. Oh, really? Okay. This is primarily verified by system test, the external stuff, because it's all external. You can run tests. They can tell you stuff. This needs the full range of verification tactics. What supports what? The basic internal guys, those two frames I showed you, support everything, including themselves. Some of the external guys support some of the mixed guys. That's what this is saying. Common characteristics. This is going to go relatively quickly. Behind every one of the 60 plus quality attributes, there are a set of characteristics. Now in the ISO standard, there's one, definition, name, end of story. That doesn't help you achieve, it doesn't help you verify, it doesn't help you monitor. Leading indicators and operational measures, right? These are things you can do to tell whether or not you've achieved something. It helps you achieve. You got a set, just a list of possible tactics to be used to achieve this particular quality attribute, which is safety, right? Now, I'm not saying you got to do all these things, and possibly this list has, another 19 things to add on to it, but in this model, you're expected to improve the model. So if there are other things that go in there, you add them. So you get smarter on the next project. Verification tactics, same thing. Sometimes, if elicitation is important beyond it's a safety critical app, then there's some questions in here. Maybe there are some tools that you can use to help you verify, for example. Resources, various pointers. Oh, look at this. People have written books about some aspect of this thing, right? You got books on security. Well, the model is not meant to have all information on the planet in the model, but it should point to major sources of good information, right, about this particular quality attribute. So some of them have lots of information, some of them not so much. And then the fourth slide, you see up here design scope. This is something that I guess I'm surprised that most developers don't understand. If you build a system and if you, for some reason, overlook a functional requirement, for the most part, that's not a big deal, right? When you discover it, before you ship or after you ship, you go, oh my God, we've got to add this functionality. Okay, it's going to impact maybe 2, 3, or 4 components of your system. Okay. If you get to the end of the project and discover that you've overlooked security or pretty much any of these other quality attributes, you are going to impact almost all of the components in the system. Ask Microsoft about retrofitting security into their operating system, right? They knew so much when they got done with that exercise, and who knows how much actual money they spent. They wrote books on how to, not on how to retrofit, but how to, put security in. Okay? Now, some of you are agilists, voluntarily or not, and you know what BRUF means, right? Big requirements up front. That is an agile anti-pattern. That is a no-no, because that smells, tastes, and whatever like waterfall, right? We don't do waterfall. We don't do big requirements up front, and that's fine. That's incremental development. I'll figure out these 7 things I want, do an increment, show it to the customer, check it a lot, get the next 7, whatever, terrific. However, with that bathwater that got thrown out, the baby also got thrown out. The baby is quality attribute requirements. Okay? If you don't pay any attention and wait for those to magically bubble up and appear, safety, security, reliability, performance, understandability, somewhere down the line in the project, that means you've written perhaps 500,000 lines of code that is insufficient because it doesn't support any of those things. That's what the phrase cross-cutting means. When you have a requirement, and there are a few actual functional requirements, like undo, right? Undo is everywhere in many systems, and it's supposed to behave in the same way in many systems, which is a constraint upon how various functions are designed, right? They all got to support undo, and so there's probably a couple of lines somewhere that say, in order to support undo, you need to do this, 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 and this, and it affects virtually everything in the system. So there are some examples, a few examples, on the functional side. On the quality attribute side, virtually every quality attribute is cross-cutting. Okay, so what's the bottom line then on this LiteRM, Light Requirements Management Quality Model? It's three-dimensional. Okay? So it's got lists, it's got structural support information about what supports what, and it's got a ton of detail in these 30-plus attributes. It's dynamic. First of all, you're supposed to tailor it to begin with because it's just a generic model, and there may be a bunch of things in it that have no relevance to your project, so throw them away, right? Maybe it's got some terminology in there that aren't consistent with the ones used in your organization. Change it. Maybe some of the lists you go, well, my favorite tactic is not here. Then add it. Okay? So you're supposed to tailor it and improve it. I need to show you this. You're actually going to write the strategies into the model. So whatever you've done for security for the last 3 times that you've done security, that's up here. And what you're going to do for it here, you know, and this current thing is here. So the model helps you remember what you've done and perhaps what you haven't done, what didn't work so well. And you can come back and go, please don't do this. This tactic looks really great, but it doesn't work for us. Okay? So we embed the goals and the strategies actually into the model. So the model keeps growing, right? Keeps getting better, more useful. I claim it is essentially complex. I also claim it is mildly defective. I hope mildly is correct. You can't write 125 pages, folks, and get it all right. It's just not possible. I am completely unable anymore. I've looked it over dozens of times to find what the defects are. But I'm sure they're in there. So, you know, find them and fix them. And it's incomplete. Oh my God, I got 60 things and it's incomplete? Yeah, let's talk about fun. Okay, so here's a little light. The video game industry earns over $100 billion US a year. I would call that big business. Okay, so here's Pokemon, $90 billion US lifetime. One of the leaders in garnering dollars, and always looking for an excuse to show off my beautiful grandchildren. We say, okay, this is a target market, but maybe not so much. 65% of American adults play video games. Okay, so how do I specify fun as a requirement? Well, in most of your systems, you couldn't care less. It's not relevant. If you're doing game stuff, it's possibly the most relevant quality attribute that I have. It can be everything else, but if it isn't fun, who cares, right? You're not going to sell any. Okay, so this just shows a particular approach called planguage to specifying how I would go about measuring the fun of my game. Okay, so here is the comparison slide, right? You saw that there were 4 different organizations. We got a list in Wikipedia. We got ISO 2510. We have the Bass book on architecture. We got Wiegers and Beatty's book on requirements. And here's, if we have to select the relevant requirements, the relevant quality attributes, if we have to specify them, specify their level and priority, and if we have to plan these 3 strategies of achievement, verification, and monitoring, then what helps? Well, as you see, the top 3 don't help a lot. They're just lists. So they'll give you minimal support in selecting, and then pretty much you're done, right? These ISO things and these 2 guys get plus signs only because they reference the ISO model. So they got their own list, and they say, oh yeah, by the way, look over there at the ISO model. They've got some structure that says that these guys support these guys. And that's important for you to know. The Bass book got a very relatively short alphabetized list of things. They do a nice job on how to specify, and they do a nice job on what strategies to achieve. The Wiegers and Beatty's book does a little bit better on specifying, as one would expect. And then, of course, now you take this with a grain of salt, because this is my model, my table, right? It was built to help you do the whole job. So that's why it's 125 pages as opposed to 1. More details about the LiteRM quality model are available on the web at quality-aware.com under the Software Quality KB, that means Knowledge Base tab. One resource is a 4-page preprint about simplistic models. Another is a book chapter about quality goals. In the same place, you can also find a copy of the model itself. The model runs on a Windows outliner called WizFolders and is contained in a WizFolders file. Please send questions to david@clearspecs.com. Anybody got any questions so far?
In my experience, my team right now is very small, and we are in an agile environment, all that stuff. So if I went to my boss and said, hey, I need time to implement even 10% of this, he'd lose his mind. And be like, we don't have the time or the resources.
Right, right. But, I mean, you know what my response is going to be. But you have the time to fix it after you field it and discover. So your team could take a midnight huddle and just say, is there anything here that looks really important to us that we're completely not paying any attention to? I mean, I don't expect you to, go out and whatever. I'm just hoping there are fragments of things, of ideas here that you may go, wow, never thought of that. Oh, that might be really relevant to our product. And just, raise your hand in some early meeting going, we just discovered, does anybody else think this is relevant to the product we're doing or changing or whatever?